welcome everybody to the last session of JSpring. Thank you all for attending. It also is the last session. You might be already tired, and also the title of the talk is Coding Your Documentation. I think the coding part is what we all like. The documentation part is maybe something we know we should do, but we actually don't like that much to do. But also, documentation is very important. I think we all know that, because if we read documentation, if you go to, for example, want to learn a new framework or a new language, at least I always go to a documentation, to the website, and if it's really a good organized documentation, it has a lot of how-tos, getting started guides, stuff like that. That really helps me. Also, if you go to a new project and there's a new member, mostly the first question is, where is the documentation of this project? What can I see? What can I already learn from documentation before I look at the code already? Although we know that it's really important to have this documentation, writing it is really something we tend to not do, with different reasons. It could be the tooling that needs to be used, or it's a distraction of writing the code. So in this presentation, I want to show that it might be fun to write documentation as well, by just including some of the coding things we do, like what we know for development of code, also apply that to writing documentation. And so then documentation might be fun as well. And also, as we learned in this keynote this morning, that artificial intelligence could also be used for generating documentation, so even that could be a part, but that's not in this presentation yet, but it could be useful. So, my name is Hubert Klein Ikkink. I'm also known as Mr. Haakje. Actually, I tend to write a lot of blog posts about subjects I like and I want to learn about, which you can find on my blog at blog.mrhaakje.com, and I work as a consultant at the company JDriven in the Netherlands. So when we talk about documentation, I want to first look at the types of documentation that we can write actually as developers for consumers of our library, of our service, or other stakeholders in a company that wants to know more about what we do. I want to look at docs as code, which is something like documentation as code, and see how that can help us as developers to write documentation easier. I want to talk about Asciidoc and Asciidoctor, which is actually a markup language. We'll see the details later on in the presentation. Also, Asciidoctor is a tool to write documentation and to transform it to different outputs, but we can also extend it even with Java. So that's even fun, that you can use the tool that generates your documentation and even extend it with code yourself. And finally, I want to talk a bit about how you publish the generated documentation you have actually written. So if we look at the types of documentation, of course, the first one is code comments. So that is where we live as developers, in the code. And we could write code comments and apply that to, as documentation for our code as well. Of course, readmes are very important, especially if you work, for example, with different repositories, microservices. A readme would be the starting board for you to learn how to install the software and how to get started, actually. Getting started guides also, of course, very useful, especially if you have frameworks, like if you want to get started quite quickly, a getting started guide is very useful to do and have. Then conceptual documentation, it's more about the concepts of your service, for example, of your framework or library you're writing. And this also contains, for example, architectural documentation, or where is the context of your service within a bigger landscape of services in a company or enterprise you're working on. And one of the nice models to use for that, for example, is the C4 model of Simon Brown, which gives you a good starting point to have a context, containers and components already there, and write that in documentation. Also, there is ARC42, that's really a kind of a German thing, but also a bit of a European thing, which is a template for writing architectural documents with a kind of setup already for your document. It's a kind of a template, but it's really useful also to have get started with writing conceptual documentation, architecture documentation. Another type of documentation is actually procedural documentation. That could be like a tutorial to get things going, or a how-to guide that could be part of it. That's something you quite often see in framework documentation as well if you go online and look at open source libraries. Troubleshooting documentation, that's something that actually comes along while you are developing and stuff is deployed in production. You might get some nice shortcuts that could prevent people from getting into trouble, and you can describe that in troubleshooting documentation as well. Finally, we have a reference documentation, which is like an API reference. So if you wrote the code comments in your Java source files, and you run the Javadoc tool, for example, then you get, of course, the API docs already. This would be a reference documentation. Could also be a glossary. So if you're on a project, most of the projects will have their own kind of vocabulary. And in the glossary documentation, you can have that in a list, and people already know what you're talking about and what a certain term means as well. So documentation as code. I come from a time when I had to write documentation using, for example, Word or stuff like that. And there were network drives with version numbers for Word documents that kind of didn't make sense as well. But luckily with docs as code, so documentation as code, what we want to try to achieve actually is documentation close to the code. When we write code, and especially this is the JSpring conference, when we write Java code, normally most people you have a Git repository where the code lives. It would also be very good to have documentation about your microservice or whatever you're writing in that repository or library close to the code as well. So in that case, when you check out the repository and it has even tagged versions, then you know the documentation belonging to the code matches with the version of that code as well. So it will be a one-to-one thing. Another benefit is if you add it to a Git repository, but I will use this one. If you use a text format for writing documentation, and it's close to your code, and it's checked into Git, Git diff just works. You can see difference between versions. It's not a binary format anymore, your documentation, it's text format. And it comes with a lot of pluses, because you can just use your normal Git diff tooling to see what was the difference between version 1 or 2, for example. Or you can easily revert back to different versions by just looking at the text that has been changed. If you would use a binary format, anything that's not text, actually, that is kind of impossible. It's just checked into Git as a binary format, and then to get the difference between versions, that's really difficult. When I mention text, usually what I want to do is not write plain text, just use markup. And a markup is a textual description of what you want to do. You give kind of a context to what elements are in the text file, but the output will be in a different format. So you will write text as a source format, but you will use tools to generate it, for example, to HTML, PDF, could be Word as well, or to other places if you want to. But that's part of a build pipeline to generate it, actually. Also, good thing about text formats and documentation close to your code, having it in the same repository. If you have an IDE, you can also write your code or your documentation in the IDE. And I really like IntelliJ. I live kind of IntelliJ, and if I can use IntelliJ also to write my documentation, I don't have to make a context switch to different tooling. I can still be in my editor. It could also be like Visual Studio Code, for example, but I don't have to switch to another editor with another interface, other rules, whatever. It's just in my same editor, in the same place. I can just skip between my code and writing documentation quite easily by switching some windows or tabs. Like I mentioned before, if you write the documentation as text and in a markup format, you can also write it yourself. You can also generate it from tools, for example. It's quite easy for tools, and especially also Java programs, to just generate text into a file. And if you have that text into a file, that could also be part of your documentation as well. And if you generate text in a file with markup, then you're already quite far already, because from that markup you can generate, for example, HTML or PDFs as well. So you can generate a markup quite easily. One of the tools that does this as well is Spring REST Docs. I don't know if you know that one, but in Spring REST Docs is an extension actually. You write tests for your microservice. So you describe, for example, the GET endpoint, the different kind of responses it can have with some example data. And Spring REST Docs will automatically create markup from it. And from that markup, you can generate a bigger documentation, and it can be part of, for example, a documentation side of your project. We also did it, for example, we wrote in a project I did before. We were kind of developing a custom DSL, and we wrote tests for the DSL to test that actually the syntax was still correct and the output was correct. But we extended that also with generating documentation. So we knew that after the tests were run, there was also documentation that was really showing how the DSL was working with already example data, and we know it worked because it was only generated if the test was correct. So if the test would fail, the documentation would not even be there. So I would already know that if the documentation was generated, it was okay, and it was fulfilling tests that generated documentation as well. Another thing for documentation as code is quite important that it is part of your build pipeline. I mentioned before, you have now a text format, but that will not be the format that end users will see. Will see in an, for example, in a website. You need to generate it first, and you can make it part of your build pipeline. For example, using a Maven plugin or a Gradle plugin, command line tooling, just that's part of your build pipeline. But documentation is now part of your build pipeline, and it can also be part of your artifact in the end. And also coming back to, it's close to the code, it's the same Git repository, you always know that what's generated is based on the code you want to have as well. I want to make a special mention actually here, which is a tool called Doc Toolchain. And I think it's even, I have the website open. See, there it is. It's a project with a lot of plugins and a lot of tools to actually, from different source formats, format to different form outputs. And it's quite nice, and also has a lot of Gradle plugins and stuff that you can use that can make it really useful to have it part of your build pipeline as well. Where is my... There we go. So what I want to talk about now is actually the format of your documentation. So I mentioned before, if you have markup as a format, which is really nice, because then it's text, you can do the diff on it, the versioning is quite easy. You can check it into Git repository, it doesn't take up too much space. And you can use an editor like an IDE, like IntelliJ, to write your documentation. And as people developing, that's the place where we want to live, right? People probably already heard about Markdown, which is also a popular markup language. Markdown only has a lot of flavors. It's not like there is a Markdown syntax, actually. There's a lot of overlap, but in certain things, there are different flavors, and everybody does it differently. Asciidoc is also a markup language, but there's only one standard. So that's the one there is. There's no flavor of Asciidoc. There's a bit of wording here. So we have Asciidoc, which is the markup definition. So that's what we use to write our text and documentation. Then we have Asciidoctor, and Asciidoctor is the tooling to generate from our Asciidoc markup files output files. For example, PDF, HTML. They can do EPUB, and also Docbook, for example, which is an XML format, which is kind of from the past, but still very useful if you want to do it, transform it to different other formats as well. And it's also available on the JVM as Asciidoctor J. Asciidoctor itself, so without the J, is written in Ruby. Asciidoctor J is written in JRuby. So the support of the Asciidoctor that's available in Ruby into the JVM using JRuby. And I also looked at the table of energy efficient languages, and Ruby and JRuby were not very low on the list, or we're really using a lot of energy. But the good thing is it's only for generating documentation. Afterwards, it's just static files. It doesn't need to be use any energy anymore, so that's quite nice. When we look at Asciidoc, how does the markup actually look like? So I want to show you an example of what Asciidoc markup looks like. So I can go to my editor, of course, and I go into my IntelliJ. And I will open a sample document, and I will open presentation mode, because otherwise it's a bit small. I hope it's readable for everybody. So on the left, you see my actual source. So that's the markup I'm writing, which is Asciidoc markup. On the right, you already see a HTML version of the text I have on the left. So this is the IntelliJ Asciidoctor plugin. So I'm still in my editor. And this is quite a very good plugin. And also you can see when I change something in my source, it will also be in the generated HTML on the left. If you know Markdown, a lot of things look similar, might be a bit different, but for example, headings in Asciidoc markup are by an equal sign. So the heading level 1 is 1 equal signs. If you have 2 equal signs, it's heading level 2. In Markdown, it's mostly asterisks, for example. But also, if you use underscores, then the text will be italics. If you use stars, it will be in bold. That kind of we can do lists. Lists can have a title, for example. A nice thing in Asciidoc is also admonitions, so things you want to kind of stand out in your text, and it could be, for example, a tip. And also in the generated part, you can now see it's kindly differently formatted than the normal text you can see here. We can have quotes, so it's kind of a block element in my Asciidoc markup. It's also generated or transformed into different HTML output. And links are quite simply just a link, and if you want to have different text for the link, you use square brackets, and it will be replaced with square brackets and still be a link. The conditions part will be shown shortly. Another the thing that I like most about Asciidoc is that you can include external files automatically. It's just part of the Asciidoctor toolchain, an Asciidoc markup. What this means is I can write documentation and reference source files from my Git repository that's close to my documentation, of course, and that's always up to date. So when it's included, it will include the current source file from the file system. It's not copy-pasting stuff. It's not like I have to have a source file from a certain version, I copy-paste it in my documentation, but then the source file changed on disk, and yeah, nobody updated the documentation because nobody knew that it was part of the documentation. And then documentation and actually the source file is out of sync. But just by including external files, this will never be the case. If those external source files even have been unit tested, you know, even the source file will always be correct. That's also a nice thing. Doesn't have to be source files, could also be other Asciidoc files, for example. So you could have a template document that includes a lot of other chapters, and then you can still have a good way of organizing documentation. Also notice we have documentation comments. So by just removing the comments, I now have included in my documentation. But also when I look in my source file itself, it's optional, but what it does allow us to have certain call-outs in your documentation of in your source file, denoted by the comment, and then the 1 and 2 you see here. And when I go back to my document here, you can see here at the bottom, I can reference 1 and 2 and give some more explanation, and when it's generated like this. It's not that nice now, so I will show one little trick. And that is something we see a bit later on as well in the markup. Asciidoc markup allows you to have document attributes. And I will like to call them document variables, actually, because it's coding, right? So our document can have variables, and the variables can have values that do certain things with your either output, or later we will see we can just reference the variable in our document, and it will always use the same value. In this case, this icons attribute allows me to change the output format. If you see this tip thing here, it's now a light bulb, and when I put it in the comments again, it's the word tip, so it's just another thing that makes it nice. But also these callouts are now nice. They're now formatted with a nice round with the number in it. So that's a little thing that makes things a bit more easier to read. Also, especially with Markdown flavors, writing tables can be like ASCII art. You have to do a lot of drawing about this looks like the table, and then it has contents. In Asciidoc, they try to do a different approach and actually make it a bit more easier. So a table starts actually with a pipe symbol and 3 equal signs, and the end of the table is also the pipe symbol with the 3 equal signs. The header is actually defined, it's optional, but defined as the first line. Then each cell will be start with a pipe symbol, but then you can just go on, and it's quite easy to do. And also you can see now on the right that the table is generated like a nice HTML table already out of the box. You don't have to do anything for it. If we combine this actually with the support for including external content, we can also write tables that get their data from a CSV file. So this could also be part of your build process. You have some source of source with data that might change or get generated from a tool. And that CSV file can just be included in your Asciidoc markup. When we apply format is CSV to a table definition, and we say the first line of that CSV file will be in header, also things we can change based on options we want to have, it will generate the correct contents. So we have here the table CSV on the right, which is like a nice table. When I go to the content, this is just the CSV content. So Also quite nice combining both tables and inclusions of external files to have nice documentation. I will just make sure that I remove some stuff here. I mentioned already before document attributes, the one we saw at the top about the icons and having fonts, but there was also another one, table of contents, which is also quite nice. If you enable it, you can now see there's a table of contents generated at the top, and now it's gone again. So these document attributes can be part of your source, but Asciidoctor tooling allows you to also pass that attribute along when you invoke the transformation process. So it doesn't have to be in your document. You can even override it from an external build process, for example, or leave it out here and just pass it on as the table of contents. I want it to be generated in the output. It's never defined in my source document, but still by invoking the correct document attributes when I invoke Asciidoctor, it will still be generated, which is also very nice. And also, let's do another thing about document attributes. They can have values. So for example, I have now a document attribute called conference with the value JSpring, and I can reference this in my documentation. So in this case, it's called conference, and it will be here. Hopefully still visible because it's low on the screen, but still. It will replace it. In this case, it's only one place, but you can imagine if you have bigger documentation, like 50, 60 pages, and there's certain wording you want to replace. If you define it before as a document attribute, it's just a change at one place, regenerate, and every place it will be replaced automatically for you. Which is pretty nice, and it also feels a bit more like programming, right? So it's documentation, you have variables and stuff like that. Finally, the kind of coding part of the Asciidoc markup that's available, you can have conditions. So you can have if statements in our documentation. This is also quite nice, right? The if statements are, you can use if-def. So that means if a document attribute is defined, show some content, and I show 2 samples of how to write that down. You can actually have the content between square brackets, but you can also have an if, in this case, not defined, so if and def, or an end if block, and then in between those, you can write even more text. It's not just one paragraph. You can do whatever you want there, actually. And based on the value of the sample is there or not, the output will change. So you can see here now it's not set. And when I change it, it's set again. So nice to know also is the GitHub and GitLab, for example, has support for Asciidoc. So if you write a README file using Asciidoc, it will automatically generate nice HTML for you, but it also supports this the if statements as well. And you can, what GitHub does, at least does, it adds some document attributes already for you, and based on the value of those document attributes, you can even include content in GitHub and not in GitLab, for example, but that's something you can do as well. And finally, if you look at what we can do even more, not only looking at if a attribute is defined or not, and based on that, show content or don't show content, we can even evaluate certain expressions in our documentation, which is using if eval, and then we can just look at, for example, a document attribute, compare it to a value, and if the comparison is true or not, we can still have content displayed or not. And it could also be like, it's not a def, then the content is gone. If it's def, then it's... If you have numeric values, you can even use greater than, equals, and all that kind of stuff to evaluate values, and based on the evaluation, include content or not in the output. Which also feels like coding, right? It's already doing a bit of coding in your documentation. I think I mentioned all of these. So these are actually, for me, a lot of pluses to use Asciidoc markup as well, because this is something you mostly will not find in Markdown, or it should be a special flavor that's only supported by certain platforms as well. Also, by the way, the Asciidoctor J made it possible to have this Asciidoc markup and generation of markup to HTML, PDF, for example, part of the JVM. And that's also why now it can be used, for example, in a Maven plugin or a Gradle plugin. So what I mentioned before, make it part of the build pipeline. Asciidoctor J made it possible to even have it included in your JVM build pipeline, so that's also very, very nice. There is already a lot of stuff in Asciidoctor, even the markup, the stuff you can do, inclusion of files, and what we can still do is even extend it. So Asciidoctor allows you to extend at certain phases in the process of the transformation and the parsing of your markup to write extensions and then even manipulate the document before it's been generated in different phases. And it's available in Asciidoctor, and then you have to write Ruby extensions. Asciidoctor J allows you to write Java extensions. There's also, by the way, Asciidoctor JavaScript. It allows you to use JavaScript to write extensions, so there are different ways to do it. But actually what happens in a transformation process with Asciidoctor, it first parses your markup, your text actually, and turns it into an abstract syntax tree, so the AST. So that's actually a structure of the document you're writing, like have level headings, blocks of code, stuff like that, and turns it into an AST. Once the AST is done, it needs to process the AST, and finally, from that, it generates output, which could be, for example, PDF, an EPUB format, Docbook, or HTML. So this is a very simple example of the AST, what it actually gives you. On the left, you see a simple markup. So we have a sample, which is like a heading, level 1. Then we have a welcome block, and then the actual text, welcome to coding your documentation. And as an AST, it will be like a document object with a section, with a block, and then there's contents of that block. And if you have more, of course, there will be a lot of sections, a lot of blocks. And the AST is something you can still use and parse. So the Asciidoctor J is not only tooling to transform stuff, it also allows you to look into this AST and, for example, manipulate. So if you want to do that, you can still do that as well. So extensions, there are different phases in this process of parsing, where we are allowed to intervene, actually, to add extra custom code we want to do. We might want to do something special here. The first phase is actually the pre-processor phase, and that's the pre-processor extension, of course. That's actually when the hard source code file is read in, so the actual textual format that's there before it's even into an AST or whatever. But Asciidoctor allows you to write code to have some customization there. For example, you could add custom document attributes yourself before any of the other markup has been parsed or manipulated into an output. Then there's an include processor. I already showed the include part that's already available in Asciidoctor, but we can also write our own include processors. So if you want to have a different format, for example, include RSS feeds, we can write code, write an extension for that, register the extension, and it will be used in our generation. The block processor allows us to look at certain blocks in our markup. For example, if you remember from the example markup, there was a quote block, which is actually what a block processor would intervene, but we can have our own blocks defined. There's a block macro processor. It's kind of the same way, but the syntax of defining block macro processor is the block name followed by some attributes or things you want to change there. Then finally it comes into a tree processor, and there we can still manipulate the tree if we want to. So this all happens, these 5 extension points, in the parse phase of the document. Then we go to the generation of the AST actually to an output format. And then we get kind of specific. This one is kind of generic still, which is inline macro processor, which allows you to, at the state of generation, an inline is actually something that's in, for example, a paragraph, compared to a block macro, which is like a paragraph, but this is text within a paragraph where you can change something. The doc info processor, which is mostly used for HTML output, which allows you to add headers, something to the header and footer part of the generated HTML information. And there's a post processor, which kind of all documents already done, the generated document, mostly also in this case HTML, but still you want to add something to that generated HTML. So now you can also look at parsing the HTML and do stuff with it if you want to. But those extensions points already inspired some people to write extensions already for us. We don't have to write them ourselves, but I will show an example how to write them yourselves. But still, we can also reuse some of the stuff that already has been built. I will show two examples. One of them is Asciidoctor diagram extension, and one of them is the tabbed code blocks extension. So I want to see if I go to diagram. I will go to IntelliJ again, and then I have an example document. Also, and this is actually two things in one. What you can see here is not only document as code, but also diagrams as code, which is one step further ahead, because then our diagram is just text, and it will be generated in a graphical format, which is also very powerful. And we combine both with Asciidoc, with the Asciidoctor diagram extension. So now we have all text-based stuff, but it will be generated in nice documentation, even in graphical format. Now we can see on the right something that IntelliJ already does for us, but we can see examples later on how to generate it ourselves. Plenty.uml is a text description of a diagram you want to do, and this is just an example. And there are other formats as well. Plenty.uml is not the only format you can use. I know the Asciidoc diagram extension also supports, for example, the structurizer DSL that's been generated, can generate things from it. And also a thing to remember is if you're using tooling that does not give you textual diagrams, for example, it would be nice if you could, for example, if the tooling has a way of extracting that information from the tooling and export it into an external file format, for example, in a build pipeline, then you can still include the external file within your Asciidoc markup. So you can still use both, even if the tooling does not have a textual format. Of course, instead of having this all in one place, we can also, of course, get it from another source file. And I think, let's see what I called it. So it will be, and still will be included. Instead of having this block, actually what we have here, Plenty.uml, and have this include part with it, there's also even a shorter way to do stuff, which is in this generation. It's using not Plenty.uml, but a different kind of formatting. So this is like the block macro. The other one was a block processor. This is a block macro processor, which is first is the block name is the format of our diagram code, and then we can simply reference it. So now IntelliJ kind of is stuck because it does not support this syntax, but it still shows with the textual output here. So this is really ASCII-art, like this is a diagram written in ASCII-art. What I can do is generate it for using Asciidoc. I'm using the Gradle plugin to generate it. It's now done, so I can go to the generated document. Let's get to the correct. There it is. So you can already see using Asciidoctor instead of the IntelliJ plugin, the output is quite different. The coloring is different from the top diagram, but also at the bottom you can now see it's now even generated this ASCII-art thingy in a PNG format. I can also use, for example, SVG as a format, which also is quite nice to use. The other thing I want to show is the coded tab one, or tab code. So I think if you look at some of the documentation of libraries like, I know from Gradle, for example, also other libraries that support different languages, they have this kind of way of showing code samples using tabs. So you can choose, for example, Kotlin or Groovy, and based on the choice you have, that you can see the different sources in the documentation. There is, of course, there is an extension for that can make it to happen, which is actually quite easy extension. You have to follow some rules when you write the documentation, but still it works. So what you can see here, I have two code blocks, and when I use this extension, I should be able to have an output that shows the sources not underneath each other, but in a tabbed HTML page. So let's see if it's now done. There we go. So now, just by applying this extension, we don't have to write it yourself. Somebody wrote it already. Just by adding it to the class path of your Asciidoctor generation, I now have this nice way of organizing my code. And that's something you quite often see in framework documentation. But yeah, we can also do it ourselves, right? So that's not really a problem. If we want to have something specific that's not already written by somebody else, that we just can include as a jar file, we also can write our own extension. I just want to show a short example of how that extension would look like, because it's really not that difficult. That's a nice thing about it. The first thing we need to do actually is extend one of the base classes. So I will go to my IntelliJ. And actually, the first thing I actually should do is add Asciidoctor J to the class path, so I will show that as well. There we go. Also, all these examples, by the way, will be in GitLab. I will share the link shortly. In this case, I'm using Gradle to build my project, but you could also have used Maven. Writing an extension is just writing Java code, right? So I can just apply a plugin. It's called Java Library in Gradle, which allows me to write Java code. It expects that there's a source main Java directory and stuff like that. I can define dependencies. The most important one actually is the dependency on Asciidoctor J. And I also optionally included here the PDF Asciidoctor J implementation, but that's not really needed, and some other stuff. And I can write tests as well, so I defined also some test code here. What I want to show is a very simple example, and then let's go to a preprocessor extension. So what I said as the first step is you need to extend a base class. And for each of the extension points we have in Asciidoctor, so we have the preprocessor, block marker processor, block processor, etc., there is a base class. In this case, we're writing a preprocessor, so we extend from the preprocessor. And that base class has a lot of nice utility methods that allows us to handle, for example, document reading and stuff like that. That's not really that important. What I want to do here is add some custom document attributes, so like the variables of our document, by applying this extension. And these will be the system properties, so just system.getProperties from Java. And I filter on everything that starts with Java dot. So everything that starts with Java dot should be a new document attribute, and I should be able to reference that document attribute in my markup language later on. And also it does some customization here. It replaces the dots with hyphens to kind of have a different naming in our document attributes. But that's actually all it does. So you notice here, there's only one method I need to override for an extension. It is for all the extensions I'm writing. If you have the correct base class, in this case preprocessor, or block processor, or docinfo processor, there's always one method you need to override, and it has the correct arguments already to interact with either the AST, for example, or the document that you're reading, or applying stuff that you want to apply here as well. So it's really not that difficult. Also, I can write tests for it. And the nice thing is, for example, I have this test here. That's the first test. I can even do assertions then. So that's quite nice. So I can have an extension and do have assertions. What I actually need to do is to make sure that Asciidoctor, when it tries to convert my source, in this case, it's in this part here, I say convert, there's a string value, and I want to have a Java-version, so that would be the Java system property Java.version. And I want to assert on the result. But before it knows, Asciidoctor knows that this preprocessor is actually part of our class path, I need to register it using Java extension registry, and I can say that's a preprocessor implementation and then the actual class name of the implementation. So I just want to make sure that the test is still green. There we go. Yeah, all test has been passed. It is in the bottom. So it's quite easy to use Asciidoctor in your test as well to have this implementation I've written tested for completion. Another thing I can show, I did add another method, which is actually not a test method because it does not have an assert, but it allows me to generate a document. And I already did that one before. So let's see. That was the Java props HTML. And I want to show also the original Asciidoc, of course. Then. So this is my markup, and it references Java version, Java VM version, Java vendor. IntelliJ has a really nice support for Asciidoc. It already says, yeah, this is something that's not supported automatically by Asciidoc, but yeah, I know I've written the code to actually make it available. So once it's generated, you can see now it includes the version, and then all the document attributes has been replaced with the correct values. It's nice that I can add a custom extension in my tests using this Java extension registry. But what I actually want to do when you write extensions, like the other tabbed code extension, for example, it's just a jar file. So what I need to do to make my extension also available for other people to use, I need to package it as a jar file, but I also need to make sure that I can register it available for Asciidoctor. So what we need to do, we need to implement the extension registry interface, which is also just a single method we need to implement, which is register. And this is the same what we did in the test code. Just add the Java extension registry, say that we have a new preprocessor and the class name of the preprocessor implementation. And once we have this in place, we're almost there to make it available. We also have to make a file that's in, let's see if I can, yeah, it's in, yeah, here you can see it, meta-inf services, and then the file name is a given for us, that's org.asciidoctor, whatever there is. And it contains actually all the lists of the implementations of the extension registry interface, which allows me to add this to the class path of Asciidoctor. So in this case, I could create from this project a new jar file. It could contain almost 7 extensions, custom extensions that can be used by other people or other people in the project in their markup and use it automatically from there. So it's not that hard to do. That's a good thing. So you need to register extension and you need to package it. One final thing I want to mention is that Asciidoctor tooling itself already allows you to generate from the markup an output like HTML and PDF. But if you want to go a bit bigger, like static site generators, on the JVM there's JBake, which uses Asciidoctor markup as source formats and allows you to have even bigger sites like blocks or whatever you want to do. There's Antora, which is written by the people that originally started Asciidoctor. It's JavaScript, so the extension should be written in JavaScript. But the nice thing about Antora is it allows you to define kind of recipes for your documentation. It will be a big documentation site, but you also reference, for example, Git repos and tags of Git repos. And it will automatically a big site for you and allows you to look at documentation from different versions of, for example, microservices in one go, and it will just generate it for you. It's quite nice. The Swiss Army knife of converting source to any other format you want to do is Pendoc, if you don't know it yet, but that's a command line tooling, Unix tool actually. It allows you to have different input formats and have different output formats. And there's a really big list of things they support. And for example, it allows you to, in Asciidoctor, HTML is supported, PDF support, EPUB is Docbook is supported. But for example, not Word. You cannot have the markup of Asciidoctor and generate it to a Word document. But you can generate a Docbook, and Pendoc has Docbook to Word support. So then, with an extra step, you have the build pipeline, of course, already, so it can still be part of it. I mentioned Confluence. A lot of companies they use Confluence, and they're like, oh, write the documentation on Confluence, but nobody that. Then we still have the differences between versions is a problem. You can also use Confluence as a kind of read-only thingy. So you write your documentation using Asciidoc markup generated to HTML. Confluence also stores the information of the Confluence site in HTML. It has a REST API, so it allows you just generate it in a build pipeline, use the REST API, and then have the generated Confluence site. So even business can be happy as well. So thank you for listening to this. I hope it gives some ideas, that documentation doesn't have to be boring or have to make context switching. It can be fun. It can even give you, Asciidoctor gives you the opportunity to use your coding things you already know and apply it to documentation. I've only shown one extension now, but for all the extension points, I've written some of the extensions in Java, which is available on GitLab as well. And one thing I want to show as well, because you need to kind of eat your own dog food, right? So in the part of publishing, the presentation you saw was actually also, there we go, Asciidoc. In this case, it was transformed into Reveal.js. So even that is possible. You can write your presentation in Asciidoc. So thank you very much for listening. Enjoy the drinks and the bar. And I'm still available here for a question, but it's 5 o'clock, so the people just want to leave. If you have questions, you can come to me, and thank you for listening.